This is how helicopters shattered speed limits and evolved into machines that rival fixed-wing aircraft performance. From dependable transport aircraft to experimental speed machines, this countdown reveals how engineers pushed helicopters beyond limits and redefined what vertical flight can achieve in modern aviation. 12. Augusta-Westland AW139. At number 12, the AW139 establishes the modern benchmark for helicopter speed. This aircraft reaches approximately 310 kilometers per hour. That alone places it among the faster helicopters used in daily operations around the world. But what makes it important is not just the number. It was designed for balance. Offshore transport, search and rescue, executive travel. Speed was never the primary goal, yet it still performs at a high level. That raises an important point. If this is considered standard performance today, then what happens when engineers stop focusing on balance and start chasing pure speed? Because that shift is exactly what comes next. 11. Sikorsky S-76. At number 11, the S-76 proves that longevity can compete with innovation. This helicopter reaches around 287 kilometers per hour. Slightly slower on paper, yet still relevant in 2026. Now consider this. It first entered service decades ago, yet it continues to operate in executive and offshore roles worldwide. That is not accidental. Its design was refined over time to maximize efficiency, comfort, and aerodynamic stability. But there is a limit to how far refinement can go. At some point, improving the same design no longer delivers major gains. So the real question becomes clear. What happens when engineers stop improving and start rethinking the entire system? 10. Bell 525 Relentless. At number 10, the Bell 525 introduces a different kind of evolution. It reaches speeds close to 296 kilometers per hour. But its real breakthrough is not speed. It is control. This helicopter uses fly-by-wire technology. Instead of direct mechanical inputs, the pilot's commands are processed digitally. That allows for smoother, more stable flight, especially in difficult conditions. Now think about that for a moment. If the aircraft can stabilize itself more effectively, it reduces risk at higher speeds. So suddenly, the conversation changes. Speed is no longer just about engines or aerodynamics. It is about how well the aircraft can manage itself in motion, and that opens the door to more aggressive designs. 9. Airbus H160. The H160 takes a quieter, more subtle approach. It reaches speeds around 287 kilometers per hour, but its real innovation lies in its rotor design. The blades are shaped to reduce drag and noise while improving airflow efficiency. This may seem like a small change, but at higher speeds, even minor aerodynamic improvements can have a major impact. Here is the key idea. Helicopter speed is not only limited by power, it is limited by how air interacts with the rotor system. So instead of forcing more power into the system, engineers are redesigning how the system interacts with the air. And that leads to a bigger shift, because some helicopters completely abandon traditional rotor setups. 8. Kamov Ka-52 Alligator. At number 8, design philosophy changes completely. The Ka-52 uses a coaxial rotor system, 2 main rotors spinning in opposite directions. No tail rotor. This configuration improves stability and eliminates energy loss from the tail system. The result is a top speed of around 300 kilometers per hour. But here is what really matters. This design gives the helicopter better control at high speeds and during aggressive maneuvers. Now imagine this in a combat scenario. Speed combined with precision. That is where performance becomes tactical. And once speed becomes a tactical advantage, engineers start pushing even harder. 7. Boeing AH-64 Apache. The Apache is not just fast, it is built for survival. With speeds around 293 kilometers per hour, it carries heavy armor, advanced sensors, and a full weapons system. That combination should slow it down, but it does not. Instead, it maintains high performance under extreme conditions. This reveals something important. Speed alone is not the goal, it is speed under pressure. The ability to move quickly while carrying weight, operating systems, and surviving threats. But even with all this engineering, the Apache still faces the same fundamental limitation. Traditional helicopter designs can only go so fast. So what happens when that limit is challenged directly? 6. Mi-28 Havoc. The Mi-28 continues this progression. It reaches speeds close to 300 kilometers per hour while operating in all weather conditions, day or night, clear skies or complete darkness. It is built for reliability in extreme environments. But here is the deeper insight. Speed becomes more difficult to manage when visibility is reduced. So maintaining performance in those conditions requires advanced systems and precision control. Now consider the implications. If a helicopter can operate at high speed in the worst possible conditions, then its design is approaching the limits of traditional engineering. And that is where the next shift happens. 5. Sikorsky UH-60 Black Hawk. At number 5, the Black Hawk represents consistency at scale. It reaches speeds of about 294 kilometers per hour and is used across multiple mission types: transport, combat support, rescue operations. It does everything. But the real story is durability. This helicopter has been in service for decades and continues to perform reliably. Here is what stands out. It was not designed to break speed records, yet it remains competitive. That tells you something about its engineering, but it also highlights a gap. Because even the most reliable helicopters still operate within the same speed range. And that range is about to be broken. 4. NH Industries NH-90. The NH-90 introduces a structural shift. Instead of focusing only on engines or rotors, it reduces weight through advanced composite materials. This improves efficiency and allows it to reach speeds around 300 kilometers per hour. Now think about the strategy. Less weight means less resistance. Less resistance means better performance. So instead of adding more power, engineers are removing limitations. This approach is subtle but powerful, because once you reduce enough limitations, something interesting happens. You create space for entirely new designs to emerge. And that is exactly what we see next. 3. Sikorsky X2. At number 3, the rules change completely. The Sikorsky X2 is not just an upgrade, it is a breakthrough. It reaches speeds of approximately 460 kilometers per hour. That is a dramatic leap beyond traditional helicopters. So how is it possible? By combining coaxial rotors with a rear propeller that provides forward thrust. This solves one of the biggest problems in helicopter design. At high speeds, traditional rotors become inefficient due to aerodynamic limitations. The X2 overcomes that barrier, and once that barrier is removed, speed increases rapidly. But this is only the beginning of a new category, because another design pushes this idea even further. 2. Eurocopter X3. At number 2, the evolution becomes even more aggressive. The Eurocopter X3 does not just improve on existing designs, it rethinks how a helicopter generates forward speed. Instead of relying only on the main rotor, it adds 2 side-mounted propellers. These propellers provide additional forward thrust while the main rotor maintains lift. The result is extraordinary. The X3 reaches speeds of approximately 472 kilometers per hour. That places it far beyond the limits of traditional helicopters and into a category that overlaps with fixed-wing aircraft. Now pause and consider that. A helicopter moving at speeds comparable to small airplanes. That was once considered impossible due to aerodynamic constraints. But here is the key detail. The X3 does not remove the rotor, it enhances it. This hybrid approach allows the aircraft to maintain vertical takeoff capabilities while dramatically increasing forward speed. And that creates a new type of machine. Not quite a helicopter, not quite an airplane, something in between. But even this is not the final step. Because one aircraft is designed not just to prove the concept, but to bring it into real-world operations. 1. Sikorsky Boeing SB-1 Defiant. At number 1, the future becomes real. The The SB-1 Defiant is not an experimental concept in isolation. It is part of a next-generation military program designed to redefine battlefield mobility. It builds on the same core idea introduced by earlier high-speed designs: coaxial rotors combined with a powerful rear propeller. But this time, everything is refined for operational use. The aircraft has already demonstrated speeds exceeding 460 kilometers per hour. That is more than double the speed of many traditional helicopters in active service. But speed alone is not the goal. Range, stability, and maneuverability are equally critical. And the SB-1 is designed to deliver all three at once. Now think about the implications. A helicopter that can travel at airplane-like speeds while still taking off and landing vertically. That changes logistics, response times, and mission capabilities. Troops can be deployed faster. Rescue operations can reach remote areas quicker. Combat missions can adapt in real time with greater flexibility. This is not just an improvement, it is a transformation. And here is the most important part. This technology is not theoretical. It is being actively developed for real-world deployment, which means the future of helicopter speed is no longer an idea. It is already in progress. From reliable transport helicopters to experimental machines that rival airplane speeds, the evolution of helicopter design reveals a clear pattern. Each generation pushes slightly further until a breakthrough changes everything. Today, that breakthrough is already happening, and the line between helicopters and airplanes is starting to disappear. If you found this breakdown insightful, make sure to like, share, and subscribe for more deep-dive documentaries like this. Which of these helicopters surprised you the most? And do you think high-speed rotorcraft will replace traditional aircraft in the future?